Hello, in this video we'll be going over the basics of calculating voltage, current and resistance using multimeters and gaining measurements from them. So, what is voltage? Voltage is the difference in charge between 2 points. It's measured in volts, therefore it is represented by the letter V. What is current? Current is the rate at which charge is flowing. It's measured in amps, therefore it is represented by the letter A, and in some cases the letter I. What is resistance? Resistance is a material's tendency to resist the flow of charge or current. It is measured in ohms and is represented by omega. Formulas for calculating voltage, current, and resistance. In this chart you have all the formula required to calculate voltage, current, or resistance if you have two of the variables. How to correctly connect up voltmeters, ammeters, and ohm meters. So in this picture we're shown a basic circuit. Where I know it's a basic circuit is that there's a power source, a load which is the resistor, and a path for the current to move about the circuit. In the next few images I'll be showing how to connect the voltmeter, ammeter, and ohm meter correctly within the circuit to get the correct readings needed. In this picture we have the ammeter correctly installed. To do this you must break the circuit and install the ammeter within the system from where you broke the circuit. The ammeter is most commonly incorrectly put into the system by placing it directly across from, say, in this case, the resistor. This is wrong because in the case of the ammeter you have to pass the current through the ammeter to get the reading of the current. In this picture we have the voltmeter set up. To correctly install the voltmeter, what you must do is place the probes across the component for which you want to measure the voltage. The voltmeter is one of the more simple meters to install within the system. In this final picture we have the ohm meter set up. To set up the ohm meter, what you must do is remove the component completely from the circuit that you want to measure. So say if it's a lamp, you can't just turn the power off and unhook one side, you must just completely remove it from the circuit. Otherwise you won't get a correct reading. How to use multisim. In this next part I'll be going over briefly on how to use multisim on a basic level. So here we have the main workspace. Now to place components you go up to place component. Here you could be scrolling through ages trying to find the component that you need. And there is a search function if you know what you're looking for. But instead we'll be going to source and getting your basic power source. In this everything needs a ground, so we'll be using a ground as well. And we'll be using a resistor to set up a basic circuit, as well as an LED, which is found in diodes. And here I'm trying to find a switch to make it a open-close circuit, but I couldn't remember where the switches were, in fact. And this is me failing at trying to find the correct switch that I wanted, because I couldn't remember what it was called in multisim. But once you have your components, you go to wire so that you can hook it up. So what you do is just click and drag, and just hook up parts up. Now, you might not be able to see it, but there's a small dot on the circuit which allows you to, it's just a junction. Here you see me grab a multimeter which acts kind of like it acts either as an ammeter, ohm meter, or a voltmeter, depending on how you have it set up. So here I'm setting it up as a voltmeter, just as a demonstration. Double click it to get up the UI, and click the simulate button. Now, as you can see, shows the voltage running through it. You have to stop the simulation to make any changes to the program. And that's the basics on how to use Multisim. How to use multimeters. In this picture we have a digital multimeter. Now the main thing I want to point out is the dial. Now that's the range switch. The range switch allows you to choose the function, so you could use the multimeter for voltage, current, or resistance. Now some people might be confused with what the numbers represent. Well, as you can see in this picture, it's pointing to 200 with the straight volts. That means a direct current of between 200 volts. So the numbers just represent the range of what the parameter you're searching for is within. It's quite common nowadays to have a digital multimeter that actually has auto range. So all you really would have to do is select the function that you want, and then off you go. So here in this picture we have a multimeter currently set at 2 volts, so the range is 2 volts or lower. Now I'm using an alkali battery that is rated for 1.5 volts, so this meter is just reading the total voltage, which is 1.582. And in this next picture we have the multimeter set at 20 volt range. So again, same battery reading 1.58. The difference between this one and the previous one is that it gives us a less decimal placement. And here we have the same multimeter set to 200 volts. The reading is 1.6. Now, obviously, as we get higher up the range, we're going to get less decimal places for the volt reading. And finally, we have the voltmeter set to 1000 volts. Now, the reading is 001. This usually happens when your range is too large for the object that you're trying to read the voltage of. The same thing happens when, in this case, on this multimeter, you set it to 200 milliamps. It will read 1 at the beginning. Again, it means that your range is too small for the object. In this picture we have an analog meter. Now there's two main parts to an analog meter: the range switch and the scale. So using an analog multimeter can be difficult because on the scale there are different scales. At the top you have the AC, DC, blue scale, which is used for the DC volts, AC volts, and DC milliamps. Then you have the green scale, which is used for the resistance. On the range switch, obviously you have the DC voltage, AC voltage, the resistance, then DC milliamps. The main thing to know about an analog multimeter is what the numbers represent. In this one we have 30, that represents 30 volts. So on the scale, when there's a full deflection to the right, as shown on this picture, it reads 30 volts. Now say that the needle was halfway to the 15, that would mean it reads 15 volts. But say that the volt range was set to 10, you would read the lower blue scale as the full range. Also, say that the range is set to 100. Since this meter doesn't actually go up to 100, you would use the bottom blue meter, that is when it's at full deflection at 10, and just times it by 10 to get to 100. So then whatever, say that it got to say 4, you would have to times that by 10 to get your correct reading. So here's another example. We have the range set to 30, which means we'll be using the top blue range. Then it's just a matter of finding what the voltage is. In this case, it's 15. In this example, we have the voltmeter set to a range of 3 milliamps. So you find what scale you're using, that would be the top blue one, and since there is no free scale, we'll be dividing everything on the top scale by 10 to get it down to 3. So that so in this example, we have a current reading of 2 milliamps. I hope this final example helped understand how to use an analog meter, because it can be one of the more difficult things, but with practice it's easy to understand. So that's all there is really in the basics of calculating voltage, current and resistance, placing meters correctly within circuits and using multimeters. Thanks for watching, and I hope this was of some use to any students that are learning about circuitry. Alright, bye.